Between the United Kingdom and the rest of Europe lies a narrow stretch of water known as the English Channel. From above, it spans just over 30 kilometers, a deceptively small distance. Yet for millennia, this body of water acted as a natural barrier, a wall separating two worlds. Between the United Kingdom and the rest of Europe lies a narrow stretch of water known as the English Channel. From above, it spans just over 30 kilometers, a deceptively small distance. Yet for millennia, this body of water acted as a natural barrier, a wall separating two worlds. Then humanity chose to go beneath it, not across the surface, but under the ocean floor. And there, deep below the waves, exists one of the greatest engineering wonders ever built. The Channel Tunnel, a structure more than 50 kilometers long, often described as an underground highway linking Britain and mainland Europe in just a 20-minute journey. But what makes this tunnel so extraordinary? And how did engineers bore through rock, water, pressure, and wildly complex geology to create one of the boldest transportation systems on Earth? Let's descend below the surface and uncover the answers, together with MegaRise. Since the 19th century, engineers had sketched out bold ideas to connect Britain and continental Europe with an underwater tunnel. But wars, limited technology, and concerns over national security kept that dream sealed away for generations. It wasn't until the late 20th century, when transportation needs, tourism, and economic cooperation became more critical than ever, that the UK and France finally agreed to turn the vision into reality. And they chose the most ambitious solution possible: no bridge, no floating tube, but 3 full-length tunnels carved beneath the sea. One for trains heading to Europe, one for trains returning to the UK, and a smaller service tunnel nestled between them, carrying cables, pipelines, and serving as an emergency escape route. On paper, it sounded straightforward. In reality, it was far more complex. When engineers began drilling into the seabed, they discovered that the chalk layer beneath the English Channel was far from uniform. Some sections were soft, almost like flour. Others were hard as concrete. Worse still, even a single tiny fracture could allow seawater to burst into the tunnel with enough pressure to tear through steel. So why did they dare to drill anyway? Because the blue chalk beneath the channel, while imperfect, had one crucial advantage: it is remarkably impermeable. This created a kind of natural corridor, making the idea of tunneling beneath the sea actually feasible. But feasible doesn't mean easy. The project was split into 2 fronts: British engineers drilling from Dover and French engineers drilling from Sangatte. The 2 teams couldn't see each other, couldn't hear each other, couldn't communicate through the dozens of meters of rock between them. All they had were geological maps, millimeter-level calculations, and laser-guided navigation systems. Inside the tunnels, temperatures reached nearly 40 degrees Celsius, hot, humid, suffocating. Tools shook violently. Every meter forward was a battle between human engineering and the weight of the ocean above. And then, on December 1st, 1990, the impossible happened. A technological miracle that is still considered a benchmark of precision in modern tunneling. Inside the Channel Tunnel, an underground city running 24/7, most people think it's just one long tunnel. In reality, the Channel Tunnel is a complex, high-tech system. Giant ventilation units constantly circulate air through all 3 tunnel sensors, monitor temperature, toxic gases, water ingress, and seismic movement. Massive fireproof doors, each weighing several tons, can seal shut in seconds. Electrical cables, telecom networks, and pipelines stretch across the entire 50 kilometers length. Eurostar trains race through at more than 160 kilometers/h, yet passengers barely feel any change in pressure or temperature, thanks to engineering solutions hidden deep behind layers of concrete and steel. Everything is built around one principle: human safety comes above all else. There are things machines simply cannot do, and that is why the workers and engineers became the most essential force behind the entire project. They faced countless challenges. The constant threat of sudden groundwater intrusion, overheated drill heads, rapid fluctuations in air pressure, unpredictable geological shifts, yet they pushed forward day after day. Every meter excavated was a testament to their skill, their patience, and their belief that they were building something far beyond ordinary human ambition. Today, as the Eurostar glides through the tunnel in just 20 minutes, it's hard to imagine that only a few meters away lie millions of tons of seawater and layers of rock formed over millions of years. The Channel Tunnel is more than a route, it is a symbol of international cooperation, modern engineering, and the ability to push beyond limits once thought impossible. It stands as a reminder that no ocean is too deep, no boundary is beyond connection, and no engineering dream is out of humanity's reach, as long as we dare to begin.